Hi students. Last year we studied about the periodic table, in which there is a comprehensive classification of elements based on atomic structure. What is the basis of classification of elements in the periodic table? You know, it is the atomic number. If you know the atomic number, we can determine its position, nature, group and period of the element. Suppose atomic number of sodium is 11. Electronic configuration 281. Group number is 1 because it is the outermost shell. Period number is 3. Period number indicates the number of shells. Is this group 1 element a metal or non-metal? You know, it is metal. In such a way that we can predict the properties of elements. We learned about various atom models. J.J. Thomson's model, Rutherford's model, Bohr model, etc. In Bohr model, in an atom, electrons are arranged in various shells around the nucleus and they are filled in the increasing order of energy. As the distance from the nucleus increases, the energy of the electrons in the shell increases and the attractive force between the nucleus and the electron decreases. Example, electronic configuration of lithium is 2,1 because its atomic number is 3. Like this, we can write the electronic configuration of sodium and argon in the table. Sodium atomic number 11, in K shell 2, L shell 8 and M shell 1. In K shell we can accommodate only 2 electrons. In L shells we can accommodate maximum 8 electrons and M shell the last 1 electron. But its electronic configuration is 281. In argon, atomic number is 18. First shell K shell 2, L shell 8 and M shell 8. What is the maximum number of electrons that can be accommodated in the M shell? It is 18. In potassium, atomic number 19, the electronic configuration is 2881. Why does the last electron of potassium go to the fourth shell instead of occupying the third shell? It reveals the limitations of the Bohr model. Accordingly, electrons in each energy level are arranged in its sub-energy levels. Each sub-energy level in a shell is called a subshell. They are named as S, P, D and F. In K shell, which is a first shell, has one subshell. L shell has 2, M shell has 3 and N shell has 4. See the subshells present in each shell shown in table. First shell, one subshell, that is S. In shell number 2, 2 subshells, S and P. Shell number 3, 3 subshells, S, P and D. Shell number 4, 4 subshells, S, P, D and F. Which is common to all shells? It is S. How can you identify the shell in which each subshell belongs to? Let us give the serial number of the shell to the symbol of the subshell. For example, 1 is to indicate the S subshell of the first shell. and 2s for the s subshell of the second shell, and so on. See the table. Shell number 1, one subshell, that is s. Subshell represents 1s. In shell number 2, two subshells s and p. Subshell represents 2s, 2p. In shell number 3, three subshells s, p and d. Subshell represents 3s, 3p and 3d. Shell number 4, four subshells s, p, d, f. Subshell represents 4s, 4p, 4d and 4f. You know the maximum number of electrons that can be accommodated in each shell. Then how many electrons can be accommodated in each subshell? In shell number 1, maximum number of electrons that can be accommodated in each shell is 2. It has one subshell, 1s. It can accommodate 2 electrons. In shell number 2, maximum number is 8. It has two subshells, 2s and 2p. 2s has 2 electrons, 2p can accommodate 6 electrons. In shell number 3, maximum number of electrons that can be accommodated in each shell is 18. It has 3 subshells, 3s, 3p and 3d. 3s can accommodate 2 electrons, 3p can accommodate 6 electrons and 3d can accommodate 10 electrons. In shell number 4, maximum number of electrons is 32. It has 4 subshells, 4s, 4p, 4d and 4f. 4s can accommodate 2 electrons, 4p can accommodate 6 electrons, 4d can accommodate 10 electrons, 4f can accommodate 14 electrons. The maximum number of electrons that can be accommodated in each subshell is given in the table. See the table. S2, P6, D10 and F14. In the textbook, table 1.4 is given. Complete the table and write it in your notebook.